There we go. Okay, so in this particular case, in graph B, as the x variable increases, the y variable does what? It decreases. So now we have two kinds of slope, an uphill slope, which is a positive relationship, a downhill slope, which is a negative relationship. In a positive relationship, the two variables do the same thing. They both go up. In a negative relationship, when one goes up, the other goes down. Okay, here we have a little question here. We've got some data. And actually, I'm just going to make sure you guys all have a ruler. 1, 2, 3, 4, 5. 1, 2, 3, 4. You have room. Perfect. Anyone this way have their own ruler? That's okay. Don't do the 4. 4. Yeah, that's the top. Okay, so the first thing we're going to do is you're just going to look at this data and you're going to tell me what kind of relationship is there between the hours of study and the test score. Is that a positive relation or a negative relation? Take a look at this data. Is that a positive or a negative relationship? What do you guys think? Positive. Okay, so it's a positive relationship. And the next thing we're going to do, and I wonder actually if I can do this on the board so that you can see it a little better. So I'm just going to move this down. Let's see if this works. There we go. Okay. Now, here's the trick. When you want to draw a line through this, because we want to show the overall trend, what we don't want to do, winding for me, do not play connect the dots. Do not do this business, okay? I can't even reach up there to do it, okay? Don't do that. I need my step stool. I left my step stool in Mr. Look's classroom. I'll be right back. Oh. Okay, sorry about that. What you want to do is you want to get your ruler so that it goes kind of right through the middle of the lines. You want to have approximately the same number of points above the line as you have below the line. Would this be a good line? Not really. Even though I've got the same number above and below, does it follow the trend? No. Does this follow the trend? No, it's too steep, right? It's got to be somewhere in the middle. And I'm going to pop that back up again and I'm going to draw it because it's easier to draw like this. There we go. So grab your ruler and draw a line there. This is called, there's 3 names for it. It's called a trend line. And why is that? Because it follows the trend. It's also called the best fit line. It's also called the line of best fit. Are we okay? Oh no, I'm sorry. Okay, line of best fit. Tiana, do you have your workbook? Okay, cool. So we good with that? We got 3 different names. We got trend line, we have best fit line, or line of best fit. Okay. So there's another word for relationship. Relationship is also called correlation. So you can have a positive correlation. Do you see how it's still got the word relation in it? Co-relation. They are relating together. This is a negative correlation. Which direction does a positive correlation go? Uphill or downhill? Up. And negative goes down. And that kind of makes sense, right? If you're in a positive mood, you're feeling pretty up. If you're in a negative mood, you're feeling pretty down. Okay? So here we have some examples on our next page of our trend line, our line of best fit, our best fit line. It should follow the trend. It should have approximately the same number. You don't really need to write this down because it's actually right in here. Yes?
Can you go back to the other page?
Oh, yeah, I can go back to the other page for sure. Yeah. Here? Yeah. Okay, cool. No problem. Yeah, if I ever move too quickly for you, or if you miss something, feel free to tell me to go back. Okay, so it all follows the general trend of the data. So really, you didn't have to write it down again. And you should have approximately the same number of data points above and below. So if we count these, I got 1, 2, 3, 4, 5, 6, 7 above. And here I have 1, 2, 3, 4, 5, 6, 7 below. Over here, I've got 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, 6, 7 above. That's pretty close. It doesn't have to be exact. You can just be kind of like close enough. Okay. If you really get into science, eventually you'll be putting all your data into a spreadsheet like Excel, and it will graph your data for you, and it will make your best fit line for you, and it will make it mathematically the best fit line you can. It's really the truly best fit line. Do these graphs show positive or negative correlation? Negative. Excellent. A good trend line should have the points distributed above or below. I would like you to take a look at these 3 lines and decide which one do you like best. Do you like graph A? Do you like graph B? Or do you like graph C? Tell your partner. Which line do you like best? We like C. Why do we like C? Tell your partner, why do you like C better? What is it about C that makes it better than A or B? Anyone want to give it a try? What makes this graph the best? It's even. What do you mean it's even? Yes. On the other hand, on this one, I have 1, 2, 3, 4, 5, 6. And here I have 1, 2, 3, 4, 5, 6. So I have this one has the same number above and below, but it's not as good. It looks nicer. Did you notice that all the ones that are above the line are over on the right-hand side of the graph? And all the ones below the line are over on the left-hand side of the graph? You don't want that to happen. You want them to be evenly distributed along the graph. And in fact, one of the techniques that you're going to learn, if you want to, is that if you draw kind of a blobby shape around all of your data points, if you draw a blobby shape around all of your data points, your line should go right through the middle of the blobby shape. Now, if you're actually drawing a graph, do you think you should leave the blobby shape there when you're done, or do you think you should erase it? You should erase the blobby shape when you're done. Just like that. Okay. We're going to practice drawing our blobby shape here. So let's try drawing a blobby shape on our next page. And then, once you've got your blobby shape drawn, what will you do? You will take your ruler. It's always best to have a see-through ruler so you can see through it, and you will put it in the middle of your shape, and you will try to cut that shape in half. That's not bad. I might want to put it a little bit higher, actually. Okay, and no one is looking for perfection. We're only looking for good enough. Is good? Good enough is good enough. So you draw your blobby shape. You add a line that divides it evenly. And then you cut it in half and erase your blobby shape. Try it again. You have a choice. You can either draw the shape or you can just put your ruler in the middle and try drawing your line. Okay, so try putting the ruler in the middle of this one and drawing your line. I can't hold it up high enough to do it. Yeah, I feel like mine isn't really very as good as it could be because I've only got 1, 2, 3 below, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 above. So maybe I should raise mine a little bit. Yeah. Okay. Other types of correlation. So we have positive and negative correlation. We also have high correlation and low correlation. High correlation is also known as strong correlation. Low correlation is known as weak. Take a look at these two diagrams. We've got high over on the left, high, strong on the left, and we have low, weak on the right. And tell your partner what is the difference between those two. They're both a positive correlation. One is strong and one is weak. What's the difference? Okay. What is the difference between high and low correlations? Yes. Yeah, one's kind of tidy and one's kind of all over the place, right? If you were to draw your blobby shape, this one here is a much more narrow blobby shape. This one here is like, it's very, very blobby. Yes? So if we were to draw our best fit line through that, and you guys can draw your best fit lines through those, you'll notice that all the points are close to the trend line. So that is a strong correlation. Strong or high. Whereas our other one, oh my goodness, if I try and draw like a line through this, it becomes harder to figure out where I'm going to cut it in half, right? I'm like, is that really in half? I don't know. And we have points far from the trend line.
Wait, this man.
Yes.
You had to let both like 5.
I don't know. Let me count. I've just eyeballed it really. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it would probably actually be better if I did it more a little bit like this.
I got like both like 5 or 11.
Yeah, and I think yours is probably better than mine. I'm not being particularly careful. Okay, once again, we've got a high and a low correlation here, but this time, are they positive or negative? This time they're negative. Draw yourself a best fit line through each of those. Everyone, draw your best fit line through your high and low negative correlations. Okay. Now there is another type of correlation, and that is, oh my gosh, what is this? Every single point is on the line. That's not just a strong correlation, that is a perfect correlation. Perfect positive, perfect negative. Positive, of course, goes uphill, and negative goes downhill. And sometimes if you're doing something like plotting the mass of water versus the volume of water, you will get perfect correlation. Okay? All right. Here is just a summary. So we have perfect, positive. We have strong, positive. What's the other word for strong? High. We have weak, positive. What's the other word for weak? Low. And then guess what? There's also this thing. What's happening in this graph? Nothing. There is no correlation. It's just random. It's not going up. It's not going down. It's just everywhere. Yes, there's no up or down. It's just no correlation. And then, of course, we have perfect, negative, strong negative, weak negative. We already talked about that. And has anyone ever heard the expression, correlation does not necessarily mean causation? Anyone ever heard that expression before? It is super important when you are looking at studies. Just because one thing goes up at the same time as another thing goes up does not mean that one causes the other. Okay, just because there is a strong correlation does not mean that one set of data is causing the effect. You would have to do some thinking about that. You would have to make sure all your other variables are controlled. Okay. Correlation tells us how well two things relate together. We have that strong correlation or a weak correlation or a perfect correlation. Causation says that one variable actually causes a change in the value of another variable. So if I have a greater volume of water, if I have a bigger volume of water, what will its mass be? Will it be bigger or smaller? Bigger volume of water has a bigger mass. I mean, that's pretty obvious, right? That is a case of causation. The more water you have, the more mass it will have. We're going to look at a case, though, where two things go up, but they're not actually causing one another. It's a very silly example. So during the months of February and March, we looked at the jars of strawberry jam that were sold in a local market in New York. At the same time, we also looked at the number of units of a popular gaming console sold in Florida at the same time. Well, and if we look at the graph, here we have the jars of jam sold in New York. And as we go this way, that is increasing. What's happening to the number of gaming consoles sold as the number of jars of jam goes up? It's also increasing. Do we see a correlation here? Yes, there is a correlation. There is a what type of correlation? There is a positive correlation. And in fact, we could put another word in front of positive, strong or high. Now, does it seem likely to you that people buying jam in New York is causing people in Florida to buy gaming consoles? No. So this is where we have correlation, but not causation. They're both going up, but one isn't causing the other. What's likely is, and you can draw your trend line in there, what's likely is something else is probably making both of them go up. Have a little think about that and see if you can think of something that might make sales of jam and sales of gaming consoles both go up at the same time. Maybe what? Anyone have a maybe they want to share? Maybe. Sorry? Advertisement. Yeah, maybe there was like a whole advertising push for both of them at the same time. That could have been. Any other maybes? Yes? Yeah, there could have been sales going on at the same time. Absolutely. Okay. You might also have a growth in the US economy, right? Maybe the economy was just better, so everyone had more money, so they could buy more jam and more gaming console. They could just buy more of everything. Okay, so here is our hypothesis, is maybe it is that the US economy made game console, if this goes up, then this goes up, but also it makes that go up. But it is not correct that the jam sales do not cause, that looks like donut. I'm going to change that. Do not cause an increase in that. Or maybe it was just a coincidence. That could be too. Okay, we've got a few little exercises for you to do here. So why don't you try to draw the trend line and describe the correlation for numbers 1 through 8. Okay? Okay, so folks, you can do pages 99 to 102. I'll come around and take a look and see how you're doing on it. All right, just make sure you, if you have any questions, make sure you ask me. Yes. Yeah. And that one is going up though. Folks, don't forget to draw the trend line for numbers 1 to 8. 1 through 8, you're also drawing the trend line. And it's no correlation. Okay. And not even just weak, it's just no correlation at all. Yeah. Yes. What would it you could maybe argue either way on this one. It's down here, it looks low, but up here it looks higher. So you know what? I would not make one like that on the top. Hi. As soon as Aaron comes back. Yeah. Yeah. I would never ask that. Yes. So if you are to take your line, you're going to take are the sheets close to the trend line or are some better bars on other sheets? Then looks like nothing left. What were any questions?
Yeah, so I just lost it. Or you might have Yes. This will be a wrong
Oh my God. No wonder you want to miss these songs. Dude, I was crazy. You should have. You should have.
I would love something like
Here he is.
Yeah.
You get.
Okay, now. Yeah, who's lost it? Yeah. Yeah. This is why.
You're always
Oh, you just have. Yes. Yes.
So we draw a line, if you want to. Oh.
Lies outside of that. Liar, L-I-E-R.
Just so you guys know, because this is like the most common mistake I see like all the time. The word is out, L-I-E-R, outlier, not outliner. And it's because it lies outside of the regular data, outlie. Oh, someone took it. You can.
Yes. I would be something else around that. Yeah. And then one would come close. Right. Three. Yes.
Just like.
I'll get my things.
One like right in the bottom for us. She walked out. For the cool film, the air conference and then telling you Stacy to test the one.
Yeah. Like the.
Yes, you know this. He said he's long.
This is one of the things. It doesn't happen to everyone. Some people's hair is higher. Like there's not as many hair. And mine is doing that in there. I'm like, is it worse? So I appreciate your cooperation. Just in case. And like, right? Because people are always like, and she just, that's like personal, that she made it. Yeah. Yeah. Well, she did. Too much now.
They were sagging so much.
Yeah, no, it's fine. I didn't do it. Yeah, yes.
So, can I get one?
Yes.
Are we gonna do some muscle?
Sorry?
Are we doing some muscle?
We will do something else just for like the last 15 minutes or so. Yeah. I'll give people another 5 or so minutes to finish up.
And we're all me.
Okay, in just a couple minutes, we're going to move on to page 103.
Yes. It's long. It's more obvious, so it's like, it's everywhere.
You talking about that, it would be fun.
It's just me.
Yes.
Can I go water?
Yes.
I just got extra barrel.
Sure.
I have two cats.
Oh, no. This
Okay, most people are kind of getting close to the end there. I will leave the rest of that for homework. And we're going to go on to page 103 and learn where to put the variables and how to tell which one is which. So if you recall the x-axis, which direction does the x-axis go? Side to side. And which direction does the y-axis go? Up and down. Where do you put your independent variable? Independent goes on x and dependent goes on y. So here's a little experiment about a dog. And this is actually kind of fun because my dad actually, when I was a kid, we had a beagle and he was a physics teacher and he would actually like take the beagle into his classroom and they would attach like a little ticker tape to it. And it was a little thing that would go, it's a piece of paper, long, thin strip of paper. And if you take physics, I'm sure you will use it. And it moves through a little device that goes dit, 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 just really regularly. Okay? But if it's attached to something that's moving, if it's always moving at the same speed, you'll get a regular pattern of dots. So you can tell how fast and how far this thing has moved. So this is kind of like a real life experiment. So this experiment is measuring how far a dog has run at various time intervals. So we have the how far they have run. What quantity is how far? Do you remember our quantities and units quiz that we did? That would be in meters. But that's the unit. And it would be distance, yes. And that's our quantity. And then we have various time intervals. Okay, so we have T for time, and it's measured in what unit? In seconds. Okay, so we've got distance, which is D, meters, which are M. All right. Now, which one depends on the other? Does the time depend on how far the dog has run? Or does how far the dog has run depend on the time? You like the second one? Anyone else like the second one? Yeah. It's actually pretty obvious, right? Like the clock isn't going to speed up or slow down depending on how far the dog has run. That makes absolutely no sense, right? The clock just goes, and if it goes for longer, then the dog will have run further. So that means which of our variables is the independent variable? The time. And our dependent variable is the distance. And that means that time is going to go on which axis? Time is the independent variable. It's going to go on the horizontal axis, the x-axis. Distance, is it independent or dependent? Dependent. And so it is going to go on which axis? Up and down the y-axis. All right. Whenever you draw a graph, you must always label your axes. Axes is the plural of axis. It's one of those weird words. You know how you've got like octopus and octopi? Except for that it isn't really octopi because that's like one of them's Greek and one of them's Latin, and I can't remember which is which, but octopus is actually, the plural of octopus is octopus unless you have more than one species, in which case it's octopuses. If you have different species of but it's not octopi. Octopi is wrong, apparently, so I'm told. But this is another one of those words where the plural is weird. You know, you've got woman becomes women. That's a weird plural. It's not just stick an S on the end. This is a weird plural. You don't just stick an S on the end. You don't say axes. You say axes. So axis becomes axes. And you must always, on a graph, be sure that you label your axes. Look at this. We have a light axe. We have a heavy axe. We have a double axe. We've labeled our axes. Thank you for that smile. You get an A+. Okay. Anyway, bad jokes. Bad jokes. All right. So what we're going to do is on our x-axis, we're going to label the axis with the independent variable. So we're going to say, what is my independent variable? My independent variable is time. So we're going to put time. So we put the quantity, and then in brackets, we put the unit. So that's going to be seconds. Along the y-axis, now I'm going to give you two choices here. Don't write anything down yet. I'm just going to see which one you like better. Do you like it looking like this? Or do you like it better looking like this? Do we like option A or do we like option B? Okay, option A is correct. Okay, if you like option B, I'm sorry, but we always do option A. So we don't go this way. We always have it starting at the bottom and going up. I don't know why. So this is distance in meters. So once again, we have the quantity. And we have the unit in brackets. So you need to label your axes. You also need something up at the top. You always have to have a title. And there are several ways to write a title, but I'm going to teach you the easiest one of them. The easiest one is dependent variable versus independent variable. Dependent variable versus, are you guys familiar with that little abbreviation for versus? Okay. Independent variable. So which one always comes first? The dependent comes first and then the independent. So another way to say that is your x variable versus your, or sorry, not your x variable, your y versus your x. But we would never just write y versus x. Instead, we would write, who is our y variable? That one there, we have distance. What do we write next? Versus. And then we have our x variable. So distance versus time. And you could get a little fancy and say for a running dog. For a running dog. But that last little part is optional, okay? Probably if you're in grade 11, you'll be required to do that, but for grade 9, as long as you get distance versus time, I will give you full credit. Yes? So literally anytime you draw a graph, you are going to get a mark for having the quantity and the unit in brackets on the y-axis, the quantity and the unit on the x-axis, and then the y variable and the versus and the x variable. Okay? And we haven't even started drawing dots yet. But you've gotten like 1, 2, 3, 4, 5, 6, 7 marks or something ridiculous like that. Okay? And we are just about out of time, so I think I'm going to leave it there for today. This is your homework plus page 73. Actually, not all of page 73, 73 numbers, what to what? Let me look. 73, D through F. If you want to do the whole thing, you can do the whole thing, but D through F is all that's required, okay? And if you could return the rulers, please, that would be grand. Thank you so much. You're welcome. Yes. This is the rewrite, right? Mm-hmm. Yeah. Making measurements. There we are. Yeah. Okay. So.
Sorry.
No worries. Okay, so we have here. So 27 to 29. Yeah, 37 to 40. Take a picture of that. Yep. 37 to 40. Yeah. Actually, say 37 to 42 because some of that is necessary for a quiz. Okay?
This is because I'm doing this week?
Yeah.
So like tomorrow I didn't have.
Yeah. And I think 41 and 42 are useful for that quiz. And then 54 to 59. 61, number 5. 65. And then yesterday's was 48 to 51. Plus 72. 99. 102 plus 73 D to F.
Oh, terrible.
Yeah.
That's good. You guys are so really.
That's
Yeah, I'm talking about like.
What you got? Yo, I used to talk with that. I just. Not worries, have a key word. Plastic doesn't go in the back. I ate one. I'm actually, wait. Oh. Oh, that took it up. I'm just adding. Whoa! Where did the soul? Actually,
No, I'm not saying you.
I can then you have to half by.
Yeah, this one. Yeah.
Like, look at just the roots. Oh, yeah.
Not